guys, in this video let me explain the basic set operations in detail along with some examples. Operations on sets. The two sets can be combined in many different ways. For example, starting with the set of mathematics major and set of computer science majors in a college, we can form the set of students who are maths major or computer science major, and the set of students who are joint major, that is both in maths and computer science, and also the set of students not majoring in mathematics. Like this, we can form so many different ways you can form sets. Okay, so the two sets can be combined in many different ways. So the basic set operations here we have used are union, intersection, difference, complement and symmetric difference. Let me see one by one detail. Union of sets. So the union of two sets A and B is defined to be the set of all those elements which belongs to A or B or both. That is denoted by A union B. So you can define A union B as set of all x such that x belongs to A or x belongs to B. For example, let me here take two sets A and B. A consists of elements A, B, C, D and B consists of elements F, B, D, G. So, writing A union B for this set, you can have first you write the elements of A, that is A, B, C, D, and writing the elements of B, that is F, B, D, G. Okay, look at here, these two sets are equivalent because in a set if one or more elements are repeated mean the set doesn't change. Here look at here A, B, C, D, again B is repeated. The set cannot change if one or more of its elements are repeated. So B repeated two times, also D repeated two times. So instead of writing two times, you can write once, that's enough. Okay. So A union B is equal to A, B, C, D, F and G. So which means either one of the set has the element, you can write, that is if the elements belongs to A or B, so you can combine the elements of A and B. Okay. So if one or more elements are repeated means you can write it once, that's enough. Next, taking the elements of A as 1, 2, 3, 4, 5, 6 and element of B as x, y and 5. So here 5 is an element in both A and B, so you can write only once, that's enough. And writing the remaining elements of A and B, so that will gives you A union B, that is 1, 2, 3, 4, 5, 6 and x, y. So here I won't write A 5 because already we have take the element in the set A. Here the element is repeated in set B, so no need to write it two times. Write it once, that's enough. Okay. Next, intersection. Second basic operation on set theory is intersection of sets. That is intersection of two sets A and B which is denoted by A intersection B. That is a set of elements that belongs to both A and B. If the element belongs to both A and B, then only you can say, that is you can write A intersection B. That is A intersection B we can write it as that consists of set of all x such that x belongs to A and, not or. Okay, and the very important word here, and x belongs to B. For example, here I have to take two sets A and B. So A consists of elements A, B, C, D and B consists of elements F, B, D, G. Look at here, the elements belongs to both A and B is an element of A intersection B. So A intersection B consists of the set of all elements that belongs to both A and B. So look at here, A is an element of here the set A alone, so leave this. B is an element of both A and B, so you can take it. So the element B belongs to both the sets A and B. Next, C. So C is only an element in A, so leave this. Next, D. D is an element both in A and B, so you can take it. And also in F and G also one of the elements of B alone, so leave this. So A intersection B consists of only B and D. So next, the second example, let me take the set A consists of the elements 1, 2, 3, 4, 5, 6 and B consists of the elements 5, 6, 7. So here only the two elements 5 and 6 are common to both A and B. So A intersection B here is only the set consists of the elements 5 and 6. So intersection means that belongs to both the sets, then only you can take A intersection B, that is the set of elements of A intersection B. Next one is difference of sets. So the difference of two sets A and B is the set of all those elements which belongs to A and not belongs to B, that is A minus B. Okay, so you can write A minus B as the set of all X such that X belongs to A and, okay, use the word and correctly, and X doesn't belongs to B, which means the element that belongs to A but that is not an element of B, then you can write the elements of A minus B. Okay, you can give you the set of elements of A minus B. Here A minus B, you can also refer this as or also known as the relative complement of B in A. A minus B is also known as the relative complement of B in A. Okay. For example, let me take the two sets. A consists of the elements 1, 2, 3 and B consists of the element 1, 3, 5, 7. So in such cases here we can list out the set of elements of A minus B as, so you know already A minus B means this element that belongs to A and not belongs to B. Okay. So here look at here, A consists of the element 1, 2, 3. A is an element of both, 1 is an element of both A and B. So leave this. Okay. Leave this element. And 2 is an element of A but not an element of B. So you can take 2. Next, 3 is an element of A but that is also an element of B. So leave this. So we have here, we take into consideration of only the elements of A alone, not of B. So A has only 3 elements. Among the 3, only one element 2 alone in A. So A minus B consists of only the element 2 alone. That is a singleton set, isn't it? Set consists of only one element. So A minus B consists of only one element 2. Next, for the same example of sets having the same elements A and B, so you can write B minus A. In B minus A, you can take in first the set B and you can write down the set of all elements which belongs to B and not an element of A. If so, 1, 3, 5, 7. So look at here, 1, no, that is an element of A, leave this. 3, so you can write 3, no, that is also an element of A, so leave this. Next, 5 and 7. So you can write 5, 7 because that is not an element of A, because A consists of only the elements 1, 2 and 3. Okay. So only 5 and 7 is an element belongs to only B. Now that is not an element of A. So A B minus A consists of only the elements 5 and 7. Next example, if A is a set consists of the elements 8, 4, 6 and B is an element consists of element the same set 8, 4, 6. Okay, here A and B only the name, that is a set's label only different, A and B, but having the same elements A, B, 8, 4, 6, 8, 4, 6. In that case, what is your A minus B? A minus B is an empty set. And what is your B minus A for this case? B minus A also empty set because both of them having the same number of elements and also the same element. Okay. So in this case A minus B and B minus A, both of them is nothing but an empty set. Fine. The next one, complement of a set. So the complement of a set is, here we take U is a universal set. If U is a universal set and A is any set in that universal set, then the set of elements which belongs to U but not belongs to A, which is called complement of A, and you can write the complement of A by either by A dash or A complement like this or A bar. Okay, you can make use of any of the notations, okay, as you like. So all of them represents the same meaning. So you can write A complement as, that is A dash, that is equal to set of all X such that X is an element of U and X is not an element of A. Or in other ways, using difference of sets, you can write this as A complement as U minus A, isn't it? That is set of all elements which belongs to U but not belongs to A. That is A complement, isn't it? So either you can write A dash in a set builder form like this, or you may make use of the difference of sets. You can define A dash as U minus A. Okay. Now, for example, let me take the set universal set U as 1, 3, 4, 5. Sorry, 1, 2, 3, 4, 5, and the set A consists of only the odd numbers 1, 3, 5. So, in such cases, what is your add A dash? So, leaving the elements of A. The elements of A is here is 1, 3, 5. Leaving this, you have only 2, 4. That is your, which gives you A complement. That is A dash is equal to that set consists of only 2, 4. Next, let me move on to the last set operation, that is a symmetric difference of sets, or you can name it as Boolean sum too, okay, but it is most commonly known as the symmetric difference, okay, of sets. So the symmetric difference of two sets A and B is a set consists of all elements that are in A or in B, but not in both, okay. So, and is denoted by either by A plus circle B or A del B. So you can define A del B as set of all x such that x belongs to A and x doesn't belongs to B. Okay, x belongs to A and x doesn't belongs to B, or x belongs to B and x doesn't belongs to A. Can you remember anything based on this representation? Yes, if you remember, means you got the point, right? So that is, yes, A del B is nothing but, just now we have discussed, right? Set of all x such that x belongs to A and x doesn't belongs to B. Mean what is the meaning of that? That is nothing but x is an element A minus B. Okay, and x belongs to B and x doesn't belongs to A. What is the meaning? That is B minus A. That is A del B is nothing but A minus B union B minus A, which means A del B consists of the set of all elements, that is an elements of A minus B and also B minus A. Okay, so or else you can write this as A del B is equal to A union B minus A intersection B2. Okay, this is directly from this definition, and by simplifying this you can write A del B2 as A union B minus A intersection B. The next one, based on that, let me see some of the examples. Let me take the set A, B, C, D as an element of the set A, and B is a set consists of the elements A, B, Lm. So you can write A del B or A plus circle B. Both are same, represents a symmetric difference of sets. So that is equal to, either you can write any one of this form. Okay, that is equal to set consists of, what is the meaning? As I told already, that is nothing but A minus B union B minus A. That is element, that is the set of all elements that is either in A or in B, not in both. Okay, that is the meaning. So for that, what I am going to do means, I am just going to cross out the common elements. What are the common elements here? A, B, A, B. So beside that you have C, D and Lm. That is nothing but your A del B, isn't it? Okay, isn't it? That is A minus B is nothing but C, D, and B minus A is your Lm. That's all. Next, coming to this again, A is a set consists of 1, 2, 3, 4. Then let me take the symmetric difference of A del pi. So here pi is an empty set. So pi is an empty set. What is the meaning? So A minus pi union pi minus A. That is nothing but the set itself. 1, 2, 3, 4. That's all. The next third one, let A is set consists of Lm and N. Here N repeated 2 times. Then what is A plus circle A? That is the symmetric difference. You take the set with the set itself, means you get only the empty set. Okay. So these are all some of the points you may note of it. That is A is a subset of A union B and B is a subset of A union B. Like A union B is equal to B union A and A intersection B is also equal to B intersection A. A intersection B is a subset of A, like that A intersection B is also a subset of B. And A minus B is not equal to B minus A. Also A minus B is a subset of A and B minus A is a subset of B. And A minus B intersection B is nothing but an empty set, and A intersection B minus A is an empty set. Also pi dash is nothing but the complement of pi is nothing but universal set, and U complement is that universal set complement is nothing but empty set. So disjoint set, the two sets A and B are said to be disjoint if they have no elements in common, which means A intersection B is nothing but an empty set. So for example, let me take two sets A, B. Here A consists of elements x, y, z and B consists of the elements a, b, c. If you take intersection between these two sets, none of the elements is common in both A and B, which means you get only empty set, which means the two sets A and B are disjoint. That's all. This is only for your reference. Okay. So, thank you.